All right, folks, let's now take a look at the practice problems here. We're going to look at problems 2 and 4 on the handout here. So problem 2, we're told that the radius of a cylinder is 2/3 its height, and the cylinder has a volume of 96 pi. We want to determine the total surface area. So I guess the first thing we want to do is just, visualize the cylinder here. So it's going to be kind of stout like this. Now we're told that the radius of the cylinder is 2/3 its height. So we call the height here h. It makes sense that the radius of the cylinder here is going to be 2/3 h, right? So we have something that kind of looks like this here. All right. Now we're told that the cylinder has a volume of 96 pi. So as a result, we can start putting things together. So you can say the volume here, remember, is just pi r squared h. So we know 96 pi is pi times the radius, which is 2/3 h, all squared, times h. We know there's a pi on both sides here, so we can just drop that out. And we're left with 96 equals, let's see, 2/3 squared is 4/9 times h squared times h. So therefore we have h cubed. Now I can multiply both sides by 9/4 to get rid of the fractions here. So we have 9 times, so it's going to be 9 times 96 divided by 4. So 96 divided by 4, if I remember correctly, that's 100 divided by 4 is 25, so it's 24. This is going to be 24 times 9, which is going to be 240 minus 24, 216. And then you're very fortunate here that in this case 216 is indeed a perfect cube. We find that the h is equal to 6. And since we know the radius of the is 2/3 height, so it's going to be 2/3 of 6 or 4 here. So we have important pieces of information. But of course we're not done yet. The problem asks, what is the total surface area of the cylinder? Well, you may remember that the total surface area of the cylinder was 2 pi rh plus 2 pi r squared. That was from our previous lecture notes here. So it's going to be, in this case, we can substitute everything. So 2 pi times 4 times 6 plus 2 pi times 4 squared. Well, let's see here. I guess we can just do this calculation. So let's see, 2 times 6 is 12, times 4 is 48. So we have a 48 pi. 16 times 2 is 32. So we have 32 pi here. So 48 and 32 yields us 80. And our total surface area is 80 pi. Okay. Now we can move on to problem number 4 here. Okay, problem 4. You're told that the cross-section of a right circular cylinder is a square in a plane parallel to the axis of the cylinder. So basically you have something that looks like this here. Now wait a minute, that doesn't make much sense here. If you have a right circular cylinder here, if you attempt to cut the cylinder, like this, so you can imagine like, a giant can of gelatin. If you've ever seen, if you've ever had the can of cranberry sauce, if you pour it out of the can, and you have it in the fridge for a while, it comes out as just a giant blob of a solid like this here. If we try to cut it parallel to the bases here, we're going to get circles. And note that if we try to cut it in any way, across a base here, it's not going to work out so well. Since we're told that it's a square, what ends up having to happen is that we have something that kind of looks like this. It had to have been cut, and we're actually told it's cut, in a plane parallel to the axis of the cylinder. So the axis of the cylinder actually runs like this, up and down through the cylinder here. So our cut is going to look something like this here. So this is the front facing of the cut here, right? If we were to redraw the cylinder over here, from a different perspective, right? From a different perspective here, the cut would look like this. Right? So this is from the side view here. These are both the same thing, which is looking at a different way. So now we can put this all together here. So we know that in the square has an area of 36. A equals 36 here. So it's pretty clear that this is 6 and 6. Which means that we know that this is 6 and this is 6, and therefore the height of the cylinder is 6. So we know h is 6 here. Now, we're told that the plane of the cross-section is 4 units away from the axis of the cylinder here. So again, just like with any 3D problem, let's try to convert it into a 2-dimensional problem by looking at it in a very specific way. So in this case here, it makes sense to look at it from the bases downward. So we're going to look from here down. Alternatively, you can look from the bottom up. That works too. So if we were to do our thing here, remember that this is a right circular cylinder, so we end up with a circle here. Our axis is now goes up like this. Actually, our axis comes up like so. So it's like this, our pen coming out of the paper here. And this the nice part about the square is that the square, because the square is parallel to this axis here, when you look at it in this direction, the square collapses to a line segment like this. Okay, so let me call these points here A and B, and here's O. So now we're told, so we already know that the side of the square is 6, so I can label that here. And we're told that the plane of the cross section is 4 units away from the center, which means that the perpendicular distance here, remember it's always a perpendicular distance, this is 4. Now this looks very familiar from what we remember about circles here. We know that this is going to be a radius here because it connects to the center and it's perpendicular to a chord. It's going to bisect the chord here. So that tells us that this point here, let me call it C, this C is halfway in between, so AC is 3 and BC is 3 as well. So that means the radius of our cylinder is going to be OA here, and it's pretty clear I have a right triangle of 3 and 4 here, so the radius is going to be 5. So now we know the radius is 5 here, so therefore the volume of the cylinder is just pi r squared h, so it's pi times 5 squared times 6, which is, in this case, 25 times 6 pi. 25 times 6 is 150, so we end up with 150 pi.